The first type of temporal data, irregular temporal databases are called type 1 irregular temporal databases. In type 1 irregular temporal databases, okay, every transaction can appear at its own timestamp, but the condition is the timestamp has to be distinct across the transactions. Like you can see here, 1, 3, 8, and so on. So in every transaction, okay, timestamps are unique. Although the gap is irregular, the timestamps are unique. In type 2 irregular temporal databases, multiple transactions can appear at the same timestamp. For example, at the same timestamp, bread jam, bread butter have appeared. These type of databases are very common when we are collecting Twitter dataset or e-commerce dataset, because like Amazon and Rakuten, they collect vast amount of data every second. So at the same timestamp, multiple people will be purchasing the item. So we often generate type 2 data sets in this situation. So the algorithms in PAMI can handle any of these three types of databases, temporal databases. Now let us see how we create a temporal databases. What are the rules to be followed? The first rule is every row must represent a transaction. Next, in every transaction, the first element must always be a timestamp. The timestamp must always be an integer. Okay. Next is timestamp must always be relative, not absolute. It means timestamp must always start with 1. Okay, and it should go on in this continuously. Next, items in a transaction can be integers or strings. Okay. Then in a transaction, timestamp and items are separated by a separator. Please note that we do not consider timestamp as a column. So we do not use column separator while creating temporal databases. We simply treat the timestamp as an additional item in a data set. So there is no column separator, only there is within the column separator, that is either space, times space, comma, or full stop, or tab separator. Now, now let us see how do we create a temporal database. For that we are going to use two applications. One is sales data and another one is multiple sensor data. If you have watched how to create transactional databases, then this video will be slightly different when I am going to explain the examples. So let us first deal with sales data. Okay. Assume we have a supermarket. So in this supermarket, there are many items that are being sold, like bread, jam, butter, and so on. A customer visits the supermarket at a particular timestamp, that is at timestamp 1, he has purchased the items bread and jam. Okay, some quantities he has purchased and he paid the money and he left. Next, at the timestamp 3, another customer has visited the supermarket. He purchased 2 units of bread and 3 units of butter. After purchasing those items, he paid $14 and he left. Similarly, multiple customers have visited the supermarket at different timestamps and made the transactions. If we look at this data, set created by the customers, we have two important components. One is the data component and the another one is metadata component. In data component, we basically see what are the items the user has purchased. In the metadata component, we see how much money the users are paying for each item and all together. Since temporal databases do not capture metadata, we first ignore the metadata and consider only the data. So when we consider only the data and their timestamps, okay. Now this data, what we do is we group them in by timestamp and put them in a tabular format, okay, where CID stands for customer ID, TS stands for timestamp, and various items that are purchased by the customer. Since CID is not important, we ignore the information, okay, and then we simply create a temporal database by considering the timestamp and the items that were purchased by the customer. That is how we create. Please note that the first timestamp in a temporal database must always be 1. That is important because we are considering relative units of time and not the absolute units of time. So in the previous example, we have looked at non-binary data which has relative timestamp. Now we look at an application that generates non-binary data with absolute timestamps. Okay, so to measure air pollution at different areas in Japan, the Ministry of Environment Japan has set up a sensor network called AEROS. The spatial locations of the sensors can be seen with the red dots on this figure. This network at every hour has collected the PM 2.5 values. Okay, so this is the timestamp. Okay, every day at every hour, many sensors are collecting the hourly PM 2.5 values. This data, what we do is we first convert it into relative timestamp. So you can see here we have taken the first one as 1 and then we made everything relative. Once we create this relative timestamp, then what we do is we convert this quantitative data into a binary format using the domain knowledge. For example, given this data, we already know that the values more than 35, PM 2.5 values more than 35 are dangerous to the human beings. So what we do is we simply use a binarizer function that takes the data frame as an input and then converts it into a binary data frame using the threshold value of greater than or equivalent to 35. Once we have this binarized data frame, what we can do is we can simply convert the binarized data frame into a temporal database as shown here. Okay, the resultant temporal database looks like this. So at timestamp 1, S1 has recorded high levels of pollution, S2 has recorded high levels of pollution, Sn has recorded high levels of pollution. Similarly, at the timestamp 6, S1 did not record high levels of pollution, S2 did not record high levels of pollution. That is why they are not here. Only Sn has recorded high levels of pollution. So we have recorded it here. So that is how we convert the real world data into a temporal database. Now let us look at an example to create a temporal database. For this, we are going to use the terminal. So in the terminal, let us say I want to create sales temporal database. Okay, let us call it txt extension. So at timestamp 1, person, a customer came, he purchased bread, jam, bat, ball. So you can observe that we are not storing how many units of bread, jam, bat, and ball a customer is purchasing and how much money is paying. That metadata we are not going to capture in the temporal database. Next, at timestamp 1, a person came and he purchased bat and ball. Timestamp 3, a person came, he purchased bread, cheese, so on. So this way we create the temporal databases. Once we create the temporal databases, we can then input it to any pattern mining algorithm, for instance periodic pattern mining algorithm, and then we can discover periodically occurring patterns in the data. Thank you very much for listening to our video. If you liked our work, please press the like button, share it with your friends, and subscribe to our channel for further updates. If you want to know more about temporal databases, please visit the official webpage of PAMI library, which is patternmining.github.io/temporaldb.html. Thank you very much.